I wonder how fast I do that.
Oh, my head hurts. I don't know where to start.
Wow. Through a quick Google search, we can find the minimum force required to fracture your skull. We can easily find the weight of the rock. And through the power of Einstein and physics girl, we can find delta x and delta y.
Oh, I see. So that must mean that we can use F equals ma. We know the force is 2,530.12 newtons, the mass is 95.82 kilograms, and thus, by using Pythagorean theorem, we know that c squared, which is going to be our final acceleration vector, must equal a squared plus b squared. A can equal the acceleration in the y direction, and b can equal the acceleration in the x direction. By using Pythagorean theorem, we can find out that the acceleration in the x direction must be 24.519 meters squared.
Exactly, and assuming the rock undergoes a constant acceleration, we use the kinematic equation delta y or delta x equals v initial times t plus 1 over 2 at squared and the known variables in order to determine the initial vertical and horizontal velocities, and which would give us 3.64 meters per second in the y direction and 12.106 meters per second in the x direction.
That's right. Now that we know the velocity initial in the x direction and the velocity initial in the y direction, which is 12.106 meters per second and 3.64 meters per second respectively, we can use the Pythagorean theorem to find the initial. Because the initial velocity vector is a component of the velocity vector in the x direction and the velocity vector in the y direction, we use a squared plus b squared equals c squared, or namely 12.106 squared plus 3.64 squared, which will equal the velocity initial vector squared, and that gives us 12.64 meters per second as our initial velocity.
There we go.
Now that we've solved one of life's greatest mysteries, let's get to some real work.